Me? Me what? Definitely.
You must take the kick in line with where you score the try, while still being far enough away that the defenders can't run you down, like this. So to avoid this, you need to be as far away from the try line as possible, while still being within your kicking distance, like this. To calculate this, you need to take a sample of about 10 kicks and find the time the ball's been in the air and the distance it has travelled, like this. First, we need to calculate the horizontal velocity. From our test, we've already found the displacement and the time. Therefore, we just need to plug these values into the equation and we can find our horizontal velocity. Next, we need to find the initial vertical velocity. We can do this using this Subat equation. Note that our vertical acceleration is -10 and the displacement is 0. We've rearranged this to find that if we plug in our value for time, 5 times the time equals our initial vertical velocity. And now we're on to our final step. You have everything you need to calculate your maximum kicking distance. We're going to use the same Subat equation as before, but this time we're using a new time, which is the time from where you kicked it to the post. We sub in this new time into our Subat equation, rearrange, and we get a quadratic equation, which you can solve. And finally, we have to solve our quadratic equation. You may have seen this formula before, but we already have all the values for A, B, and C.
Thanks.
These are the variables we're going to be using in our calculations. First, we have time, which is the time it takes for the ball to be hit to where it lands. Next, we have vertical and horizontal displacement. To let you understand this, I have a little drawing here. Let's say the stickman is kicking a ball 10 meters. See that the horizontal displacement will be 10 meters, but the vertical displacement will actually be 0 because the ball lands at the same height as where you kicked it. And that is the difference between the horizontal and vertical directions. Then, velocity is the rate of change of displacement. And we're also going to be using this in the vertical and horizontal direction. While displacement's in meters, velocity is in meters per second. And finally, we'll be using acceleration in the vertical direction. Acceleration is the rate of change of velocity, meters per second per second. And these are the variables we'll be using.